Hello everybody, today is lesson 4 in our chemistry unit, and for lesson 4 we're going to be discussing the Bohr atom. So the Bohr atom is one of the ways that we represent the particles that make up a atom or the element. And it's a very useful model. It's used right up into university, even though there are other more detailed models that come later. This model is useful for a lot of things and a lot of ways of looking at atoms. So Bohr models give us a glimpse into a successful model for the structure of matter. Bohr models are no longer accepted as completely representing the atomic structure, but they give us enough information to help us understand the nature of atoms at an intermediate level of study. I would say even higher than intermediate. It's certainly not like the very advanced like quantum mechanics and things like that, but it is still interesting. There's a little interesting idea here just thrown in just for fun, but if you could imagine an atom being as big as a football stadium, it's worth noting that the nucleus would only be the size of a marble. So remember that we're talking about 99.9% of the atom is empty or made of electrons, and the 99.9% of the mass is in the center. So that's a pretty big difference. So when we draw these models, one of the problems with this model is that we draw it for clarity's sake. And in drawing it for clarity's sake, I'm not going to draw it as big as a football stadium, so the scale is going to be a little bit off. All right, so for nitrogen 14, what we really want to know is we want to know first the pen, how many protons, how many electrons, how many neutrons we have. So here you can see the calculation for that. Nitrogen is the 7th element. So that means that we have 7 protons. If it has 7 protons, it has 7 electrons. And if it has a mass of 14, then the mass minus the atomic number is 7 neutrons. So there's our 7 protons, 7 neutrons, 7 electrons. So now that we know these, we want to organize these into a Bohr model. So the very first thing you're going to do is draw something to represent the nucleus. Typically this is a small circle. Sometimes if you have the option to use a different color, I really recommend it. So like I might do this one in purple, and I'm going to make that my nucleus. So this is the nucleus. And inside the nucleus I'm going to put the protons and neutrons. So please, please, please always draw your protons and neutrons on the inside. And then after I've done that, I need to put the electrons. And the electrons are interesting because the electrons don't show up. It's not just like 7 electrons. That's wrong. We have to organize the 7 electrons in a certain way. So Bohr determined that there were these things called shells that he called them shells. And the shells organize the electrons around the nucleus. And they organize them in certain order, or certain number of electrons at a time. The first shell has up to 2 electrons, so you can have up to 2 electrons. The second shell has up to 8 electrons. The third shell, which we can draw also has up to 8 electrons. Okay, up to 8. Okay, so if you have 7 electrons, that means you're going to put 2 electrons in the first shell, and then you're going to put the other 5 electrons in the second shell. So this is, we label them by n, so n equals 1, n equals 2, n equals 3. Now talking about anything beyond n equals 3 for a Bohr model gets a little bit confusing and can cause some issues later on. So we're going to stick to just talking about these first 3 shells in this class. Occasionally, if we want to do something with just a couple of electrons, we might go to n equals 4. But we can have as many n's as we need in order to fill the electrons, but each shell has a different number of electrons that it can hold. Okay, so here's where what we're going to be ending up with nitrogen, and that's because first we have 2 electrons that go in n equals 1,
and then the 5 that go into n equals 2. To represent these electrons, we usually use little dots. So I'm not going to actually expect you to write those numbers that I wrote. That's just for clarity or for teaching you. So I'm going to put the first 2 electrons on that first shell. Notice they are not on the line that is the nucleus. The nucleus is a separate line. So there's a circle right around the protons and neutrons, and then a separate circle to represent n equals 1. And then I'm going to write the 5 other electrons. And when I draw my electrons, I want to try to spread them out as much as possible, because remember, electrons are negative, and negatives don't like each other. So let's keep them separate. And it's nice if you can follow a nice pattern. So if you develop a nice little pattern for yourself, then it's easier to count. So here's 1, 2, 3, 4, 5, 6, 7. 7 electrons, which is what we said we had at the beginning. Okay, let's follow along with what they did here. So we draw a large circle around the nucleus and place 2 tiny circles representing the first shell. The first shell is n equals 1, and it has a max of 2 electrons. Okay? And then we're going to draw another shell, and that's going to be n equals 2, and that has a max of 8 electrons. If needed, we can draw a third shell, which holds another at 8 electrons. So the order here is 2, 8, and then 8. And if you ever needed to go higher than that, it goes up to, I'm just doing the math now, it goes up to 18, I believe, is in the 4th shell. So, yes, 18. Okay. And then you can do another shell even after that, but that's okay. That's enough. So let's draw a carbon atom. So carbon, we want to first think about that pen. So carbon is element number 6. So it'll have 6 electrons, and because it's carbon 12, that's the mass number. Then 12 minus 6 gives us 6 for the neutrons. So the first thing we do is we write that proton number is 6. We write the neutrons. Oh, I think we just wrote 6p last time. So we'll just change colors again. So we're gonna go 6p, 6n, and then do our circle. Try to draw it nicely. And then we start filling our electrons. So the first shell can only hold 2 electrons. Please keep that straight. So I'm going to draw my 2 electrons, 1, 2, and then I need another shell to fill the next electrons. And how many electrons do I have left? I have 4. So 1, 2, 3, 4. So there's our total. We have 6 protons, 6 neutrons, 6 electrons, and so we have a neutral atom. If you want to write out how it's neutral, you can put a little 0 to represent neutral. Neutral. Protons equals electrons. Okay, so let's do phosphorus now. So phosphorus is element 15. Had to think about that. I believe it's element 15. We can always go back to our periodic table. We have one up here. Oh, I did fill in this table, so please check the notes if you're looking for the answers, or you can pause the video if you're doing the last lesson's video. So 15, yeah. So element 15. So that means that its proton number is 15. Its electron number is 15. Its mass is 31, so the neutrons must be 16. So I'm going to write protons, and I'm going to write 15 of them. 16 neutrons. Draw my circle. I'm going to change pens because I can, although I did switch them backwards from last time, but that's okay. It's more about that I did switch them as opposed to. Okay, there's my first shell. 1, 2 electrons. Okay, so I still have 13 electrons to go. So I'm going to draw another one. Okay, 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so I'm at 10 electrons, but I'm not done yet. I need that third shell. and I'm going to put in my last couple. So I was at what did I say? 8, 9, 10, 11, 12, 13, 14, and a 15. And this is where getting a pattern is really helpful. So notice my pattern makes it very easy for me to count. It even makes it easy for me to see what spaces I have left on this third shell. I can see there's a space here, here, and here for 3 more electrons if I wanted to really stuff this shell full of electrons. Okay, argon 40. Argon is element number 20, so the proton number is 20, the electron number is 20, and the neutron number is 20, because 40 minus 20. I'm debating about, wait, is argon number 20? Oh no, it's 18. Ha. Hopefully one of you was at home screaming in the screen, hey, argon is 18. Okay, so argon is number 18 on our periodic table, which means it has 18 electrons, which means it has actually 22 neutrons. Okay, let's go back to that purple, because I like that purple. So we have 18 protons, we have 18 neutrons all in the center, and then our shells, which we want to make a different color if we can, or you can work your pen, you can use a pencil and then go really hard on your nucleus to make like a dark line. And then, now it has more electrons than phosphorus, so I think I'm going to be safe in saying that I need at least 3 shells. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, isn't that interesting? Look, with 18, I actually ended up filling each of the spots, or each of the spaces. So I have a whole 8 electrons in that shell. I have 8 electrons in this shell. And I have 2 electrons here. I'm going to do the same thing for this one here. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So notice that you have to fill a shell before you can start putting electrons in the next shell. So that's one of the tricks that we want you to really learn, is that as you put the electrons down, you have to put them in the smallest circle first. Okay, I'd like you to try doing this for these elements, and I will have this done for you when we come back for our next video. Thanks for listening, and we'll talk to you soon.